Hello and welcome to Pre-Algebra Lesson 33. In this video, we're going to learn about adding and subtracting fractions. So the lesson objectives for today, we want to learn how to add and subtract fractions with a common denominator. We want to learn how to find the LCD, which is the least common denominator of two or more fractions. And then we want to learn how to add and subtract fractions without a common denominator. All right, so let me read this before we get started. So when we add or subtract fractions, we must, meaning it is not optional, have a common denominator. So when they're exactly the same, that's what we mean by a common denominator. All right, let's just start off with some easier examples where we're already given a common denominator, and then later on we'll deal with the more complicated scenario where we don't have a common denominator and we need to get one. So let's say you had the problem 1/5 plus 2/5. Well, I want you to notice that the denominator here is 5 and the denominator here is also 5. So we have a common denominator, meaning the denominators are exactly the same. So that means that I can immediately start and I can add these fractions together. But how exactly do I add 1/5 and 2/5 together? Well, let's think about that with this little pizza here. Let's say that I buy a pizza and I split it up into 5 equal slices. So let's say this is 1, 2, 3, 4, and then 5. So I eat one slice of pizza. So let me mark this out. So this is the slice that I'm going to eat. Now we know at this point that we could represent the amount of pizza that I'm going to eat with this fraction 1/5. I'm taking one part out of a total of 5 equal parts. In the terminology of a pizza, I could say I'm getting one slice out of a total of 5 equal slices. Let's say that a friend comes over and now he's going to get 2 slices out of a total of 5 equal slices, or 2/5 of the pizza. So let's say he's going to take, let me change my color up a little bit. Let's say he takes this one and he takes this one. So how much pizza did we eat together? Well, that's the addition problem, 1/5 plus 2/5. So looking at this, easily I can just count and say it's 1, 2, 3 out of a total of 5 pieces of pizza. So that would be the fraction 3/5. 3 slices out of a total of 5 equal slices. How could we have gotten this 3/5? Well, what we would want to do is have this 1/5 plus 2/5 be equal to, we would add the numerators together. So my slice plus my friend's 2 slices, so that 1 plus 2, that's going to give me the 3 slices we ate. Now notice this part right here is not going to change. This denominator is going to stay as a 5. I'm not going to add those two denominators together. I have a common denominator, so I'm just going to leave that alone, and it's just going to keep moving forward as I simplify this problem. So I start off with 1/5 plus 2/5. This equals 1 plus 2. So this numerator plus this numerator over the common denominator of 5, and then it ends up giving me 3/5. Now, when you get your answer, you want to think about, can I simplify? In this case, 3 is a prime number and 5 is a prime number, so really we can't do anything to simplify. So my answer here would just be 3/5. Let's just blow through a few of these problems. If you have a common denominator, it's going to be very, very easy. So we have 3/8 minus 2/8. So again, we have a common denominator. So all you have to do is perform the operations with the numerators and place that over the common denominator. When you're done, you're just going to simplify. So I'm just going to say this is 3 minus 2 over the common denominator of 8. 3 minus 2 is 1, and this is over the common denominator of 8. So this gives me 1/8. Now, can I simplify? No. So we'll just go ahead and leave 1/8 as the final answer. What about 7 over 13 plus 4 over 13? Again, what I want to do is add the numerators, so 7 plus 4, place that over the common denominator. I have a 13 and a 13, so this will stay as a 13. So this becomes what? 7 plus 4 is 11, so this is 11 over 13. 11 and 13 are both prime numbers, so the greatest common factor here would be 1, so this is simplified. 11 over 13 is your final answer. All right, let's look at 3/4 plus 1/4. So again, just perform the operations with the numerators. We're going to go 3 plus 1 over the common denominator here is 4. So this becomes 3 plus 1, which is 4, over 4. Now, of course, we can simplify because 4 over 4 is 1. Any non-zero number divided by itself is always going to be 1. You could think about this with a pizza. If you had a whole pizza and you split it up into 4 equal slices, and you still had all 4 slices, well, then you still have 1 pizza, right? So 4 out of 4 slices would give you 1 pizza. What about 3 over 15 plus 2 over 15? So this would be 3 plus 2, just add the numerators, over the common denominator of 15. So 3 plus 2 is 5, so this is 5 over 15. You could rewrite this. Let me just do this down here. You could rewrite this denominator as 5 times 3. And then you can cancel. 5 divided by 5 is 1. Remember, if your numerator cancels completely, you want to write a 1. A common mistake there is to write a 0. So 5 divided by 5 is 1. It's almost like we did the problem like this. Let's say I did 5 over 5 times 1 over 3, right? If we did the multiplication, this would be 5 over 15, which is what we have. So now if I cancel, this divided by this is 1. And so basically you have 1 times 1/3, which is 1/3. So that's why we get 1/3 as the simplified answer. Okay, let's look at 7 over 20 minus 3 over 20. So this would be 7 minus 3, again, just working with the numerators, over the common denominator of 20. 7 minus 3 is 4, so this would be 4 over 20. And if I think about 20, it's 5 times 4. So let's go ahead and say this is 4 over 5 times 4. So I'm just going to cancel this with this. Let me actually use a different color there so it shows up better. So cancel this with this. And then what I'll do is put this as a 1. Again, you do not want to put a 0 there. That's very common when you mark this out to see a student, leave that and then say, okay, this is 0 over 5. No, this is going to be a 1. 4 over 4 is 1. So this would be 1 over 5 or 1/5. Okay, let's take a look at 1/3 minus 2/3. So we're going to subtract 1 minus 2 over the common denominator of 3. So 1 minus 2 is actually going to give me a negative. So if we think about that, 1 minus 2, again, you can always convert this if you need to. You can say this is 1 plus a negative 2, and then just use your rules for adding integers. So this ends up giving me a negative because the larger absolute value is negative. And then you would basically do larger absolute value minus smaller. So 2 minus 1 would be 1. So this would end up giving me -1. A lot of you know that 1 minus 2, you have 1, you take away 2, you get -1. Okay, let me get rid of this. So this would be -1 over 3. Now it's important to realize that when you have fractions, if you have -1 over 3, this is equal to 1 over -3, which is equal to the negative of 1 over 3. So 3 different ways to write that. A negative divided by a positive is going to be equal to a positive divided by a negative, which is equal to just the negative of that guy. Okay, so 3 different ways to write that. It's actually really important that you understand that. And we're going to use that in an example coming up. Okay, let's look at this one. So we have 31 over 50 minus 6 over 50. So we're going to do 31 minus 6 over 50. So 31 minus 6 is going to be 25. So you have 25 over 50. And we know that we could write 50 as 25 times 2. So this would become 25 over 25 times 2. Let's go ahead and cancel this 25 with this 25. So again, that's going to be a 1. And this will be equal to 1/2. Okay, let's look at one more of these. So I'm just going to think about what happens when we have some negatives already. So we have -1 over 8 plus 5 over -8. So here's what I would do. Notice that you have an 8 and then a -8. You can legally move this up here, like we talked about a little while ago. So what I would do is rewrite this problem as -1 over 8 plus -5 over 8. That is completely legal. Again, 5 over -8, positive over negative, is equal to negative over positive. You have to have exactly the same denominators. So you need 8 and then 8. You could, if you wanted to, do -8 and -8, but I think it makes it a little bit more complicated to understand, so I'm not going to do it that way. When you look at it here, you have 8 and -8, so those are not exactly the same, so you need to do something like this here in order to do the addition. So now what I would do is say this is -1 plus a -5 over the common denominator of 8, and so here, I'm just going to put that this is going to be negative, add the absolute values. 1 plus 5 is going to be 6. So this is -6 over 8. Now we're not done because we can simplify. I think I grabbed too much there. So let me just move this over here and I'll just get rid of that and draw that back in. So with this one, what I would do is write -1 and then times 2 times 3. And then for 8, let's write 2 times 2 times 2. And I'm going to cancel a common factor of 2 between numerator and denominator. So let's go ahead and do this one with this one. You could write a 1, but it's kind of unnecessary here because the numerator is still going to have something. It's really necessary when the numerator is completely canceled out, and that's where you're tempted to write a 0. In this case, you won't have a temptation to do that. So I'm going to go ahead and say that the numerator would be negative 1 times 3 or negative 3. And this is over 2 times 2, which is 4. So this would be negative 3/4. So you could write it like this. You could write 3 over negative 4, or a lot of people just put the negative out in front. So you say negative 3/4. Whatever you want to do, it's all the same answer. All right, now let's talk about the more challenging procedure. So we're going to do adding and subtracting fractions without, so let me highlight that, a common denominator. So the first step is to find the LCD. So this stands for least common denominator. This is going to be the LCM, which is the least common multiple of the denominators. So this right here causes a lot of confusion. If someone asks you to find the LCD, they are just asking you to find the LCM of the denominators. That's all it is. Then I have here for the next step to write equivalent fractions with the LCD as each denominator. I'm going to show you how to do that momentarily. Then we're going to add and subtract the numerators and simplify. So these two steps right here, we already know how to do that because we just did a ton of exercises where we already had a common denominator and we would just add or subtract the numerators, place that over the common denominator, and then just simplify. All we need to do is figure out how do we get the LCD and then how do we write equivalent fractions with the LCD as each denominator. All right, let's jump in and just look at a problem. When we get done with this problem, I'll go back and show you why this makes sense using some pizzas again. So let's start off by finding the LCD. So the LCD is the LCM of the denominators. I know this is very confusing. The denominators here, you have 3 and 4. So you have 3 and 4. So forget about the fact that we said LCD. If I asked you for the LCM or the least common multiple of 3 and 4, what would you do? You would first say, okay, well, 3 is a prime number, so I'm not going to factor that. And 4 is 2 times 2. Well, everything has to go in. So 3 has to go in, and then 2 factors of 2, those are going to have to go in. There's nothing that's common between the factorizations. So basically, it's just 3 times 4, right? It's going to give you 12. So I'm going to erase this and say that this is going to be 12. The next part is a little bit tricky. So basically, you have 1/3 and you have 1/4. And we've said that the LCD, which is the LCM of the two denominators, is 12. So what I want to do is I want to rewrite each fraction as an equivalent fraction where 12 is the denominator. So how can we do that? Well, I could multiply the denominator here by 4, and I could multiply the denominator here by 3. Let me put my addition sign in. But is that legal to do that? Well, not if I just do it like this. What I would have to do is match this number from the denominator in the numerator. So I would do 4 over 4 here and then 3 over 3 here. The reason this is legal is because 4 over 4 is going to be 1, right? So this equals 1. Any non-zero number divided by itself is going to be 1. And if I multiply by 1, I don't change the number. So it's just like I said, 1/3 times 1, well, that's 1/3. I am not changing the number. I'm just changing what it looks like temporarily so I can do my addition. Okay, so let me get rid of this. And we're going to first multiply. So remember, we're multiplying 1 times 4, numerator times numerator, that's 4. And this is over 3 times 4, that's going to be 12. So denominator times denominator. So plus 1 times 3, so that's going to be 3, over 4 times 3, that's going to be 12. So at this point, I have a common denominator. I have 12 and I have 12. So it's just like the problems we did earlier. So you're going to add your numerators. So 4 plus 3, put that over the common denominator, that's 12. And so 4 plus 3 is 7, and this is over 12. So it's really that simple. The only 2 additional steps you need to do is to first find the LCD, which again is the least common multiple or LCM of the denominators. So 3 and 4, you're looking for the LCM of those two numbers, you get 12. Then you're going to transform each fraction into an equivalent fraction where the LCD is its denominator. So think about, what do I need to multiply each denominator by to get to a denominator of the LCD? And then you got to match that in the numerator and the denominator so that you're multiplying by 1 so that it's legal. So once you've done that, you're at the point where we were at the beginning of the lesson where we had a common denominator, and then you can just add or subtract your numerators, put that over the common denominator, and then simplify. All right, let me quickly explain why 1/3 plus 1/4 ends up becoming 4/12 plus 3/12, which gives us 7/12 in the end. So I'm going to use an example with pizzas. I think it works out kind of nicely. So let's assume that I buy 2 pizzas that are completely identical, and when I first get them, they're not sliced up. So I take the first one, the one on the left, and I cut it up into 3 equal parts. So you could say I slice it up into 3 equal slices. So 1, 2, and then 3. Now, if I eat 1 piece out of the 3 equal pieces here, well, I've eaten 1/3 of the pizza. So let's say I've eaten this right here. So that is going to be represented with the fraction 1/3. Then let's say this pizza over here, I'm going to cut it up differently. So let's say I go 1, 2, 3, 4 equal parts, or 4 equal slices since it's a pizza. And let's say that my friend, he's going to eat 1 slice here. So he eats this slice right here. So let's say plus 1/4. Well, if we try to figure out how much pizza we ate, we can't just immediately do this problem here. We know that we didn't eat a full pizza. Even though there's 2 pizzas here, the amount of pizza I ate plus the amount of pizza he ate, it's not even going to add up to 1 pizza. But we can't really figure out immediately what amount of a pizza we ate, because if I try to add this one to this one, well, those are not the same, right? So this slice is not the same size as this slice because the pizzas are cut up differently. Obviously, looking at the fact that these 2 pizzas are the same size, well, this 1/3 of the pizza is going to be more than this 1/4 of the pizza. So what can we do? We would have to slice the pizza up in such a way that we can add like parts of a whole amount. So what do I mean by that? Let's start again with this 1/3 and then plus this 1/4. So you see here now I have 12 slices. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I don't have 2 pizzas here because between the amounts that me and my friend ate, it's not even going to be a full pizza. So I'm just transferring everything in terms of 1 pizza so nobody gets confused about having 2 pizzas. So what I'm going to do now is think about, okay, if I cut this up into 12 pieces here, because that's the LCM of 3 and 4, how can I transform this amount of pizza to match over here? Well, I'd multiply this by 4/4, like we did earlier. So that would end up giving me 4/12. So if I go through and look at it, well, I would have eaten 1, 2, 3, 4 pieces of pizza had it been split up in such a way that I had 12 equal pieces of pizza. And you can see that this would be 1/3, right? So you go 1, 2, 3, 4, that's a third. Then 5, 6, 7, 8, that's another third. Then 9, 10, 11, 12, that's another third. So I still ate 1/3 of the pizza. It just looks different. Then plus, over here, I'd multiply this by 3/3. And so this would give me 3/12. So let's say that I take 5, 6, and 7 for that, and I'll use a different color. So my friend, he eats 5, 6, and 7. So now we can clearly see just by counting, it's 1, 2, 3, 4, 5, 6, 7, that it's going to be 7 pieces of pizza that were eaten out of a total of 12 pieces. We could have also just done 4 plus 3, which again gives us 7/12. All right, let's look at some examples now. So we have 1/4 plus 1/2. So what is the LCD? The LCD is the LCM of the denominators. So 4 and 2. So I think you know that that's going to be 4. Again, 4 is going to be 2 times 2, and 2 is a prime number. It's not going to factor. So basically, you want 2 factors of 2. You can think about this as 1, 2, and here you have 2 2s. So you want the largest number of repeats, and that's going to be 2 2s or 4. Let me get rid of this. And basically, in this particular case, the 1/4, you don't have to do anything with that because the denominator is already the LCD, which is 4. So then plus for 1/2, you're going to need to multiply this by 2/2. And so this gives you 1/4 plus 1 times 2 is 2 over 2 times 2, that's 4. So this gives you 1 plus 2, which is 3, over the common denominator of 4. So 3/4 would be your simplified answer. 3 is a prime number and 4 is 2 times 2. So your GCF is going to be 1 there. So really that's your simplified answer. All right, let's look at 5/21 plus 3/14. So this one will be a little bit of work. So the LCD is the LCM of 21 and 14. And so 14 is 2 times 7. And then 21 is going to be 3 times 7. So when you build this, it's going to be what? You're going to put a 2 in. You're going to put a 3 in. And then you only put in 1 7. there's 1 7 here and 1 7 here. So if it's common, just put the largest number of repeats between any of the factorizations. It happens once here and once here, so only one goes in. And let's put equals here. 2 times 3 is 6, 6 times 7 is 42. So here we would say that we have 5 over 21, and then times, let me just put this here, plus 3 over 14, and then times, let me put this here. When you think about this, you can look at this list and say, well, what do I need to get to 42? Well, basically you have 7 times 3, I would need a 2, right? So you can say 2 over 2. Also, you can take this and divide by this. So 42 divided by 21 is 2. Whatever you want to do. Sometimes people will erase this and then put this as 42, and they've lost that information, so they start freaking out. Just you can take this and just divide it by this, and 42 divided by 21 would be 2. So I need to multiply by 2 so that I can get to 42. Then over here, I would need 3 over 3. 14 times 3 would be 42. So this would be equal to what? 5 times 2 is 10 over. We know that the denominators are 42, so you can just write them in. And then 3 times 3 is 9, and this is over 42. So now 10 plus 9 would be 19 over the common denominator of 42. So 19 is a prime number, and we know 42 is 2 times 3 times 7. We just factored it. So the GCF here is 1. So this is as simple as you can get it. 19 over 42 is your answer. All right, let's look at one that's a little bit tricky. So we have negative 7 over 3 plus 2 over negative 15. The idea here is that if you have a negative in the numerator or the denominator, what I would say is to put them in the numerator. Okay, so here it's in the numerator. I'm just going to move this up here. So I'm going to say this is negative 7 over 3 and then plus negative 2 over 15. You don't want to have opposite signs in your denominators. You want to make sure that when you get a common denominator, they're exactly the same. They can't be opposites. So you wouldn't want to end up with 15 and negative 15. Here, when you think about the LCD, which is the LCM of 3 and 15, well, 3 is a prime number and 15 is 3 times 5. So basically, the 3 goes in and the 5 goes in. The 3 only goes in once because you have it here and you have it here. So you're only putting in 1. So it's just going to be 15. So this would just be, let me erase this and I'll just put that the LCD is equal to 15. We can say this equals, we'll have negative 7 over 3. I'm going to multiply this by 5 over 5 because 3 times 5 is 15. And then plus you have negative 2 over 15. So I don't need to mess with this one because the denominator is 15 and that's the LCD. So don't do anything there. So I'll say this equals negative 7 times 5 is negative 35. This is over 3 times 5 is 15. And then plus you have negative 2 over 15. Let me slide down a little bit here. So this equals what? You would just add the numerators, negative 35 plus negative 2. We know that's negative. And then add the absolute values. 35 plus 2 is 37. So this is negative 37 over 15. Now you could write this as a mixed number if you want. It's really up to you because you have an improper fraction here. So you could leave it like this. 37 is a prime number, so you're not going to be able to simplify. But you could say that this is negative what? So you could say 37 divided by 15. 15 goes into 37 twice. 2 times 15 is 30. Subtracting, you get 7. So that's your remainder. So you would say that this is negative 2 and then 7 over 15. Okay, so you could write it like that if you wanted to, or you could keep it like this, negative 37 over 15. Really, it's personal preference unless your teacher tells you which one they want. All right, let's take a look at 11 over 12 minus 3 over 20. So the LCD here is the LCM of 12 and 20. So 12 is going to be 4 times 3, so 2 times 2 times 3. And then 20 is 4 times 5, so 2 times 2 times 5. Okay, so what I'm going to do here is think about the fact that I have 2 that's common. So you want the largest number of repeats, and that's going to be 2 of them. So you want 2 times 2, which is 4. And then times, you're going to put in a 3, and then times 5. So 4 times 3 is 12. 12 times 5 is 60. So this would end up giving you 60. Okay, let me put equals here, and I'll just go down here. So 11 over 12. So what do I need to multiply the denominator by to get to 60? Well, notice that you have 4 times 3 there, that's 12. So you need another 5. So let's go ahead and put 5 here and then 5 up here, and then minus 3 over 20. Let me make this 3 a little bit better. I'm going to multiply this by, and that's not much better, so let me do that one more time. I'm going to multiply this by what? So 20 times 3 would be 60. So 3 over 3. So let's say this equals, and 11 times 5 is 55, over 12 times 5 is 60. And then minus 3 times 3 is 9, over 20 times 3, that's 60. And now we can just subtract. So what is 55 minus 9? So maybe you want to do that as a vertical subtraction. Let's borrow here. This would be 4. This would be 15. 15 minus 9 is 6. bring down the 4 there. So this would be 46. So you could say that this is going to be 46 over 60. Now, I know that 46 and 60 are even numbers. So at minimum, I can cancel a common factor of 2. So 46 would be 2 times 23, and 23 is a prime number. And then 60 is going to be 2 times 30. So I can cancel that common factor of 2 between numerator and denominator. And so this gives me 23 over 30 as my final answer. All right, what about 14 over 15 minus 17 over 25? So the LCD is the LCM of 15 and 25. So 15 is going to be 3 times 5, and 25 is a perfect square. It's 5 times 5. So this would be what? 3 goes in, and then for 5, you want the largest number of repeats because it's common. Here it's 1, here it's 2, so you're going to put in 2 of those guys. So 3 times 5 would be 3 times 25, so that's 75. So let me actually erase this and just put 75 like this. And let me get rid of this border, and I'll put equals here, and we'll just come down here. So 14 over 15, what do I need to multiply 15 by to get to 75? Well, 5. So I'm going to do times 5 over 5, and then minus 17 over 25. What do I need to multiply 25 by to get to 75? Well, 3. So times 3 over 3. All right, so 14 times 5, let me do that off to the side. It's going to be 70, but let's do that off to the side. So 5 times 4 is 20. 0 down, carry the 2. 5 times 1 is 5, plus 2 is 7. So this is 70. So let's say this is 70 over. We know that, again, this is going to be 75. And then let's get rid of this. Now you have 17 times 3. Let's do that here real quick. So 3 times 7 is 21. 1 down, carry the 2. 3 times 1 is 3, plus 2 is 5. So that would be 51. So let's go minus 51. And again, we know this denominator is 75. So let's say this equals what? I think we could do 70 minus 51 in our head. That is going to end up giving me 19, which is a prime number, over 75. So this would be simplified. Again, 19 is a prime number. We know what 75 factors into. It's going to be 3 times 5 times 5. So nothing you can really do there other than to say that 19 over 75 is your simplified answer. All right, let's take a look at one final problem. So now we have more than 2 fractions involved. So you see we have 2/3 plus 1/4 minus 5/8. So again, let me just start by figuring out, well, what is the LCD? This is the LCM of the denominators. So 3, 4, and then 8. Okay, so 3 is a prime number, so don't worry about that. 4 is going to factor in a 2 times 2, and then 8 is going to be 2 times 2 times 2. Okay, so basically between 4 and 8, you see that you have 2 factors of 2 here, but 3 factors of 2 here. So you're going with the largest number of repeats. So I'm basically going with 8 here, and then I need the 3 there. So it's going to be 8 times 3, which is 24. So let me go ahead and just say that this is going to be equal to 24. Okay, let me write this down here because I'm going to need some room. So the LCD is equal to 24. Okay, let me get rid of this. And I'm just going to say that this is equal to 2/3 times, what do I need to multiply 3 by to get to 24? Well, 8. So I'll multiply this by 8 over 8. And then plus we have 1/4 times, what do I need to multiply 4 by to get to 24? Well, 6. So 6 over 6. This is probably not going to fit. So let me move this down here. Let me actually rearrange everything and move this over here. And I'll just drag this over here. Okay. Then minus, we have 5/8 times. What do I need to multiply 8 by to get to 24? Well, 3. So this is 3 over 3. All right, let me slide down here and just say equals. So first, let me just simplify everything. 2 times 8 would be 16 over, we know all the denominators would be 24. Then plus 1 times 6 is 6, again over 24. And then minus 5 times 3 is 15, and then over 24. So when you have all these different operations going on, again, if it's addition and subtraction, that's worked left to right. So I'm just going to think about it like I have this. 16 plus 6 minus 15 over the common denominator of 24. That's all I'm really doing. So I'm going to add first, and then I'm going to subtract last. So 16 plus 6, well, 16 plus 4 is 20, plus another 2 is 22. So this is 22 minus 15 over 24. And then 22 minus 15, well, that's going to be 7. So this ends up giving me 7 over 24. Now, 7 is a prime number, so you're not really going to be able to do anything. We know 24 is 3 times 8, right, or 2 cubed. So you really can't do anything to simplify there. It's just going to be 7 over 24 for the simplified answer.